and accurate for the different languages. So these are like created to mimic standard human behavior. So it's not just meant to like produce a stream of data that is very obviously generated by any. You can actually have it produce certain nuances in the output to make it seem like an actual human is generating that data. So yeah, let's move on to the next one, which is the evolution of generative AI. So you might be familiar with the earlier rule-based systems. This is something like like our Turing tests, which were proposed by Alan Turing, and early neural networks as well as perceptrons. So I still remember back in college we studied about perceptrons from I'm guessing it was Divya. I'm sorry if I'm wrong. But these systems are basically rule-based theories. And what happened with these systems is you have a predetermined set of rules which you provide to your data, and then whatever data that comes out of your models are based on those rules. So these are general hard-coded rules which also kind of limit the models on their creative outputs. And then from early like 1980s to 2000s, we had like statistical models. So those are basically like Markov chains and probability distributions, which actually use the prior data that's available, and we can also keep updating the data with freshly available data that comes in, and then we can accordingly adjust probability distributions of what may happen or may not happen, and then provide a better set of outputs for it. And then where we actually need to generally focus into is the neural network replacements that happened in the latter of like 1980s to 1990s. So that's when most of these convolutional neural networks came into the picture. That's where we tried to generate algorithms which would kind of like were inspired by how our own neural networks, how our own brain creates neural pathways, and then provides a sort of insight into decision making on how these algorithms, try to make decisions for themselves, try to make content or predictions based on how it learns from prior data. And then we have the rise of deep learning, which happened in early 2000s. So this is another advent brought in by the increased computational power and data availability that was possible. Prior to this, we were mostly limited to CPU as well as accelerated processing. So from early 2000s, we can actually see the advent of graphics processing, which brought in a large computational advantage. Because we have systems where, you know, earlier on we would have like maybe two or three cores at most, or quad core systems like our earlier Pentium systems, and then a company like NVIDIA came in with their CUDA functionality, which brought in like a large multi-threaded performance to these algorithms, and they could also take advantage of physics simulations using code like physics and all. So to like better provide a deeper insight into these models. And then we have things like deep prediction networks by I'm guessing it was Jeffrey Hinton in 2006, which also brought in these models to trust certain amounts of data, or we can also include data which it's not supposed to be using, but it can take insights from those data and then better provide outputs on it. We also have advances into computer vision, which were brought about by improvised cameras that were bought in, improvised digital sensors, which could better leverage whatever data that's being fed into it, and then also. And then we had from the early 2000s to mid 2010s, uh, where the general like focus into generative AI came into the picture. So a multi-purpose AI was always the aim for most organizations when we look into it. Rather than having just a singular approach into this thesis, we could have something that was, you know, uh, designed for multiple usages at the same time, as well as multiple outputs or multiple insights into whatever data that happens. Another place where I see where a large change came into the picture was the transformer architecture. So this was basically brought about from a paper released by Google known as Attention is All You Need. So this basically included a set of instructions by Google researchers who were researching into how we can, train models with rather than a limited set of data into something that would include like maybe gigabytes or terabytes of data of both images, text, or anything of that sort that can be trained into these models. And then these models would basically spit out data based on this input that we're giving. And that was a large advent into how these things came into the picture. So we also have models like BERT and the GPT models made by OpenAI, which are an evolution of those initial transformer models. And the BERT variants for Google have also they've been modified now into the Gemini series, which we'll be getting into later, which are being used not just on like a computational standpoint, since it's mostly goes from cloud. We can use it on our phones, and we can also use it to to even more complex tasks that were available before using I mean using human inputs, and rather than that, we can like completely move on to a machine processed input. So that's another things that have come into the picture. And then we've also seen the emergence of few shot and zero shot learning capabilities. Rather than just having a single snapshot of data, we can have like absolutely no input into new data and then see how the model hallucinates new data. And these hallucinations can be a boon as well as a bane to most of these models. Sometimes these hallucinations might not be what we are looking for. So in those senses, we might have to actually uh, kind of cut down on these hallucinations. We might actually have to tone down the creativity of the model, and then maybe provide a more statistical output on what we do. Now these have moved on into video generation, animated images, even things like highly advanced chatbots, which help you talk to a deceased member of your family just based on prior conversations you had. So there will be a lot of challenges with these things, which we'll also be getting into towards the latter end of our presentation. And there will be efforts that are needed to improve these AI transparencies, as well as the specialized models, making sure that we don't infringe on any private data or any non-mass-produced data. So the advantage to all this evolution and this fast transformation in the military AI is kind of being democratized. Rather than having closed access, most of these models that we can observe, at least the ones that we can run from our own end, are open source. So another advantage to this will be the growth of low code AI development. Rather than developing something from scratch, we can actually use these existing frameworks and platforms that are openly available. It makes it more widely available for a larger audience. So let's move on to the domains and industries that we be primarily focusing in, and where these generative AI applications are playing a major. So let's first start with healthcare. So in healthcare, we might be actually thinking, how can generative AI play a large? So we have things like medical imaging. You might have like chest X-rays of patients, or maybe things like CAT scans, which need to be provided to a radiologist or maybe even more specialized panel of doctors. That might take a bit of time for time-sensitive medical applications. This doesn't just mean like hospitals; it also means things like on the field, like if you're an army medic and you might have a portable scanner which you might use to scan a patient reports. But rather than waiting on an output from a trained panel of doctors, you can have something like in sort of like a diagnosis assistance provided by these Gen AI models, which basically gives you a basic insight into what the data is. obviously we need to use the input of trained professionals rather than just going with these individual models. So an example I can give for that would be the IBM's Watson Health. This is a closed source model, but what it does is it assists radiologists in detecting any particular anomalies in chest X-rays as well as MRIs. So it doesn't just limit itself to chest X-rays. It also might be used for magnetic resonance of brains to detect tumors or blockages of that sort. And then we also have open source projects such as Monai. So that's medical open network by AI for AI. I think it was developed by NVIDIA and King's College London for medical imaging. Again, a similar insight into this. And then we can move on to finance, where generative AI has actually provided a sort of renaissance into places like hedge funds as well as government regulators, such as our own SEBI, which uses a couple of tools nowadays, which I'll also be showing you, which better help them into providing more insights into current market trends or detecting fraud from whatever data set is available. So one example I can give you is JP Morgan Chase's Coin, which is known as a contract intelligence platform. So what happens is you can actually train a generative AI model to go through a set of documents, and then you can analyze any sort of legal documentation, as well as we can extract any important data points that are there. So if you actually go through an end user license agreement, something that most of us just tick on any service that we are signing up on to, we can actually see that there will be a large set of legalese that's written there by lawyers, and most of it doesn't make sense to us because at the end of the day, these documents will be maybe 300 to 400 pages long with multiple paragraphs going deep into legal nuances, which might not be something that's easy for us or even an industrial professional to better understand without the presence of a large team of lawyers. So what Coin does is it actually analyzes these legal documents, and then rather than spitting out a paragraph on it, it just condenses it into finer data points or finer areas of concern, which might have to be looked into by a team of lawyers in order to better serve these purposes. And for something on the open source side of things, we have AI Economist from Salesforce. What that does is it basically has complex economic simulations and any sort of policy optimization. I earlier mentioned my experience in time series. So what most brokerage projects do is they take a large data set of maybe a particular stock, and then they do insights into it. They do data analytics onto it. Maybe use a model such as PPR or SageMaker or even XGBoost, as well as uh, like any sort of analysis into the data is provided on one particular set of stocks. Or you can also train it on multiple stocks and have multiple models ready at a time. Rather than creating a large overhead for retraining these models every day, what AI Economist does is it basically simulates a micro scale economy of maybe a nation or maybe of a particular industry, like mining or ports, or anything of that sort. And what this micro simulation does is it brings in many different aspects of data into the picture or data points into the picture. And whatever simulation that we need to implement as such, maybe it might be, God forbid, a condition of war or maybe a condition of famine, a natural disaster, and how these things, these aspects might actually affect these particular industries or domains. And then we can accordingly adjust our parameters to mitigate these conditions to better create a sort of like a buffer zone for these industries. And then for policy optimization, this it's mostly like aimed towards policy makers to better create city optimizations or financial, in case of financial institutions, you can adjust things like rate of interest or lending rates to better suit your economy of scale. And then we can move on to retail e-commerce, which is another industry where we can actually see the application of generative AI. So if you go on Amazon right now and you have product recommendations for any sort of like suppose you might be shopping for a new phone, we can actually see during those reviews for different foods, we can actually see something known as a summary of reviews, which is generated by a model. In case of Amazon, I think it's a SageMaker model. It's running on S3, which is their own cloud, obviously, and it's optimized to just read those reviews that are present under those products, and then provide you with a condensed output of how those reviews are, or what people find are the pain points or what are the primary features of those products, and we can accordingly suggest to ourselves like if this product will be a good fit for us. So it's not just product recommendation, it's also demand forecasting, which is being affected in the large. So if you're a large retailer, or even if you have a smaller retail project, you can better understand industrial trends that are happening, or fashion trends, or even customer insights into what products are being bought more. And then these models can basically spit out a better recommendation for what you might need to focus on, like what sort of inventory you might have to keep in larger amounts to better adjust for industrial trends or user trends that happen. So again, the Amazon example that I provided was a closed source example. That's a model that they use for their own purposes, and I think SageMaker does have an open source component to it as well. Or we can have something like Meta's Llama 3.1, which basically is sort of like an open source alternative for that, and it's also a smaller model as such. Or even Microsoft's 5.3, which has like models with only like 4 these are things that we can actually run on our laptops. So in case if you're a small retailer or having maybe a small chain of bakeries, we can actually use these models which are running locally based on the data that we have fed into it of previous customer trends or previous sales outputs, and then that basically gives the model a better sense of what it can predict out based on what we do. So we also have things like Apache Prediction IO for building any sort of recommendation engines based on whatever insights we have into our own business. Then we can go on to manufacturing. In manufacturing, it's a different set of use cases that we can come across. Again, it's similar to the ones that we've discussed, but also additive manufacturing is proving to be something that's coming into the picture as of recent. So earlier on, if suppose you're an automobile company, you have a car that's coming into market. So if you look at the market, like in the early 2000s, we'd have a vehicle from a particular manufacturer that would be facelifted across a few generations, but it would in essence carry the same engine or maybe even up to an extent the same body panels of the engines. But it would be just iterative like improvements onto the model. But right now, what we can see is, rather than just iterative improvements, if you actually look at the automotive industry right now, they are actually using insights from reviews of actual users in the field, and whatever newer models they come out, we can actually see that there's been a massive design change on the side of like mechanical platforms, like even electric vehicles or ICE vehicles as well. The engines might have like a large jump across generations, which earlier on would take like maybe 5 to 10 years. You can actually see that same happening in a span of months to like a single year. Uh, so it also affects quality control to an extent because maybe the earlier round of models that you have created might have like a few flaws in your manufacturing process. But rather than keeping those flaws in your manufacturing process, can use additive manufacturing, combine things like 3D printing or sintering to produce newer molds for whatever parts you're creating, which has improved on the drawbacks and flaws that were, noted on the earlier quality control process. So on the closer side of things, an example I can give is Siemens MindSphere, which basically uses AI for predictive maintenance in any sort of industry like. And on our open source side of things, we can use predictive maintenance toolbox from MATLAB. So MATLAB is again a library that we've all been familiar with on this Python side of things. So you can actually use this for things like predictive equipment failure. So you might based on insights of manufacturing data that you have, you can actually create a model which predicts where sometimes this machine might be overheated or overloaded, and you can scale back, or you might acquire a larger set of machines if possible to better tailor made. I mean, it is basically a tailor made solution for whatever you need in that sense. Now let's move on to education. So obviously, yes, I'm talking to a lot of educators right now. I'm sure generative AI might be providing like a bit of a headache for educators as such, because I was a student as well, and when I was a student, I would obviously go for the easier way for getting things done. I might actually look into tools that might have helped me to better like submit my assignments on a timely manner. And as I would usually take the easy way out, maybe on the last night of a particular submission. So what you might have noticed is these generative AI tools actually help your students to provide more data, or provide assignments in a timely manner, because it's easier for them to generate data. And another aspect where generative AI plays a major role in education is tailor-made resources into uh, like it's sort of like a personalized approach into learning as well as automated grading. So rather than having to sit in a place and go through all of your books and then created a personalized course for your students, you can actually use the courses that you've taken in the past, or the data that you've actually used in the past, the books that you've used, and then you can actually use a model to create a personalized curriculum for your students. This is something that actually we use right now in industrial use cases within TCS. If we have to, provide a particular course or a domain to an institution, we actually use certain tools to better streamline the course or curriculum that we'll be offering to these institutions. So an example that I can give you is Century Tech. So it basically provides an AI-powered learning path for multiple students and educators. So this is a platform which both students and educators can use. It's not just limited to educators. And on our open source side of things, maybe things like OpenAI Gym or OpenAI's reinforcement learning context in terms of education. So these are things which already have been trained on pre-existing data that's publicly available, and then it provides you outputs on what is maybe needed. Maybe you might be an educator who's teaching. Okay, let's talk about computer science. You're going to create a new course on generative AI, and you're going to focus on Python or R as a language. So you can actually use a GPT model to give you an outlook of what you might be covering in your curriculum, of what textbooks that you might use, or your students might find helpful, and then what are the steps that you might need to follow in your curriculum. And then lastly, I can focus on the entertainment and media side of things. So this is mostly based on the content generation as well as recommendation systems that come into the picture. So again, content generation is a very hotly debated topic, because when you think of generative AI, you actually use it on a creative basis to maybe write stories or write poems or even a storyline or a storyboard for a particular movie or a series or anything of that sort of a creative sort. rather than it being, freshly created content, you can actually call it as, a hallucinated content, or, an amalgamation of whatever has been fed into the model prior to this. So an example I can give for that on the open source side of things is Magenta. Magenta is a library by Google for music and art generation. So another example which is close source would be Suno AI. Suno AI is it's an Indian startup that basically trained a model on whatever music that was publicly available on platforms, and then you can actually use it to generate a new song based on a particular style of maybe a particular singer or a particular genre of music. And then on the closer side of things, we can actually see Netflix's recommendation algorithm. So this recommendation algorithm is nothing but you might be actually going into one of these streaming sites. You've already seen a few movies or series based on your prior searches, and these algorithms can actually see those searches and see how much of the movie you've seen, whether you have actually seen it entirely, or maybe series across a very short period of time, or maybe you've abandoned a particular movie halfway through or midway through, maybe because you didn't like it. So these recommendation algorithms can take all this raw data, refine it, and then provide you with a better recommendation for what you might be using or what you might be viewing in the future. We can also see this in a couple of places that I've not mentioned here, things like automotive use cases, wherein which you have models which help with automated driving as well as predictive maintenance. So an example I can give on the closer side of things is Tesla's autopilot. So Tesla's autopilot, as well as something like even Tata Motor Group's ADAS driving features, advanced driver aid features, which actually use models that have been trained on actual closed circuit driving on roads and highways by actual users or actual testers, field testers. And these models actually take these inputs about roads and then particular existing road conditions, or maybe things like closest road closest due to maintenance, or maybe a new speed limit that has been applied to a highway, and then accordingly adjust these models to better run on their uh, automotive platforms. And we actually also have a few open source projects on this end. So this has mostly been pioneered by Chinese automotive companies, which have actually taken these open source models and then actually taken user input into it. So this particular platform known as Apollo, and Apollo is an open source model which anyone can use to like create a self-driving vehicle of sorts. So like from what I've read, a few colleges have actually implemented this within their student projects to have a self-driving car of a smaller scale, obviously. But these open source platforms are also helping out newer players into the industry to have, rather than create a tailor-made solution for these platforms, you can actually use something that is existing, something that's already available, something that's already been modified and tinkered by users to work on a wide variety of hardware. Also, okay, so, in our state of Kerala, we do have a large agricultural industry. Uh, it's not just things like crops or crop cycles or even predictive planting that might help. Generative AI can also help you to better modulate for crop yield and whatever prediction that you might need for pest detection or even pest mitigation. So we have some things like the Climate Corporation's Field View, which is being used by wheat farmers in Gujarat as well as US and all for precision agricultural input. So you might the model might actually give you a particular input into when is the most adequate time for you to plant your crop, or when is the most adequate time to de-weed your crop. Add in fertilizers or weedicides and pesticides. And also, there are things like Plant CV, which is an open source project for plant phenotyping as well as analysis. So this basically gives you an insight into the current crop that you have, and how you can actually use maybe GMO based crops for better output or better yields from your own existing crops with advanced soil analysis, as well as a nutrient analysis of whatever soil is present. Uh, so I'm sorry, I think it kind of skipped ahead. So another place where we can actually look into things is things like chatbots for customer support from retailers, as well as even education institutions. So rather than going through a human uh, PPC project, you might have a large team of humans working on maybe on certain solutions which might actually not be there anymore. So suppose you're in a bank. An example that I can think of is you're in a bank and you have a net banking platform. Uh, Maybe the user just might have doubts about where I can deposit a check online, or maybe how I can do a NEFT transaction. So rather than going through a human input for a simple task, you can actually train LLMs as well as audio models to better sound like humans, which might not be even obvious to the customer who's contacting the bank for this particular thing. And then if it's a simple input from the user, these models can actually directly provide them the steps that they need to take, or that they can proceed with in case of simple query. If the query is indeed complex, these models can actually analyze that query and then provide an insight into an actual human operator who might use the currently existing data and then speak to the customer with whatever is available to him already. And yeah, there are these things where chatbots, where things like Google's dialogue flow for any sort of conversational interface, maybe even something like a RAG model or a RASA or contextual AI systems that we can train on whatever private data that we have, and then host locally in case of an open source alternative. Uh, so I can talk about a few more industries, or do you want me to move on to a particular use case? In or do you have like a question on any particular industry that you might be thinking? I can actually take interest with your.
So it'd be useful if you could explain us with a few use cases on the generative AI connected with any of the domains that you have just shown on the slide.
Okay, okay, like
That any researcher, any person who's doing research can basically uh, make use of. If you explain with regard to some use cases connecting some of the domains, that will be helpful. I feel so.
oh, so I'll be getting onto hands-on, like a hands-on approach into these things, as well as use cases that someone can use right now, down the line in the presentation. Like what I meant was, if there's any particular industry that you feel might get insights, or any particular industry that you're thinking of right now that might be using any sort of generative AI, or a platform that might be available. I can cover that right now, or I can move on to a generalized, like what you asked for, a generalized approach into how this might be used. So I'm guessing I can move on, or if there's any other questions on this. If there's no other questions, I can just go on.
You can proceed, sir.
Okay. So I'll just start with NLP use cases, because NLP use cases are the most easiest ones that we can actually think of right now. So, like, ma'am, you had asked about, what we can do as an end user, or what tools we can use as an end user. The first thing that I can actually provide a deeper insight into is language translation, because this is something that I worked on for my end as well, for customers. So earlier on, you might have, sources like Google Lens, or even Google Translate, that we use to just translate strings of text, or even uh, give you the correct pronunciation of things. The thing about generative AI is it's not uh, words or pronunciations. You can actually use it to translate things like documents, like PDF files, or even docx files, or even this presentation which I'm presenting right. We can actually use currently existing models to translate this into a different language, which makes it easier for currently existing like education institutions, or even a large conglomerate to better serve large demographic. So it hasn't just it shouldn't just be limited to an English speaking populace. You can actually tailor make presentations or documents to better serve people from different regions. Maybe you're trying to bring in inroads to a country like Brazil where Portuguese is being spoken. And even if you don't have a native Portuguese speaker in your team, you can actually use generative AI models to take your existing set of documentation and then translate it to Portuguese or Spanish in case of Mexico. Even in India, we might actually have documents which might be in Hindi or English or even Malayalam, and we might have to move on to a different part of India where a different language is being spoken. Maybe it's a dialect of Assam which might not be spoken commonly among us. So we can actually use existing models or existing NLP models, use that, train a transformer model, and then provide outputs on it. So I've included two examples here: Helsinki NLP Opus as well as Beacon. So I can actually show you how this is being done. If you get it, I'm going to share it in the window. So I'll just show you a quick document that this is something that was made by Intel on the Spanish side of things. Uh, so this is for a particular tool known as Grit, which it was using. And as you can see, I can't speak Spanish, so I can't really understand what's happening. So we have a tool known as Beacon. So this is a close language model. This basically takes an input in the form of PDFs or Word files, Excels, or even PowerPoints, or even it can be just normal text that's present. You can just type in what you want. And the advantage to models like these are, like, in case of Google Translate, you might have noticed, like, you might actually translate something from English to Hindi. And then when you try to translate it back from Hindi to English, the context of that particular statement that you've included might change. Like, certain nuances, certain words that you use might change from language to language. And that's where, a context aware model comes into the picture is very important. So in this case, we actually have this document in Spanish, and then we've actually fed it into something like DeepL.
Sorry, Abraham, are you sharing something? It's not up.
Oh, okay, yeah, sure. Okay, should be visible now. Is it?
Yep.
Yes. Okay, okay. So this document is in Spanish, like I said, something that we might not always be able to translate, or might not be able to understand. A few words here and there, like Intel and future skills and all, might be in English. So these are things that we can understand. And when you feed it into a model like DeepL, and you get an output from that, you can actually see that up to an extent, the context of the document is being saved. So things like fonts as well as font sizes, or even the layout of the document is being saved. And we can actually see these things like is a word here, and you can see that the actual phonetics of the word has not been uh, preserved as such, but the actual translation as well as whatever's in on the translation side of things have been processed, as well as the general layout of the document has also been saved. Since this is a closed source model, I would also like to point out to something that's more open source. So this is Health and NLP. It's also known as Opus NLP. It's a publicly available repo that we can have both on GitHub as well as Hugging Face Transformer. And what this does is basically it's a model that's been trained on a large set of languages. So we can have things like so that's Mandarin, or maybe things like even Spanish as well as French. And all these models, what we do is rather than just focusing on a large set of languages, you can actually have a smaller model that's running on just a few set of languages. So maybe let's check out one in random. Let's see what all it does. So this is a basic model that's used for translating from Arabic languages to North Germanic languages. So rather than going for a broad approach, you can actually have these particular models that focus on a single language that you want to focus on, and then you can actually run this model locally. You don't even need like a really complex system to run it. You can actually run it on things like Intel Developer Cloud or even Google Colab. It's actually a fairly small model as well. It's just got 238 million parameters. So it's again a safe tensor model. So it's again completely open source. And you can actually go onto the GitHub link, and they'll actually they have provided deeper parameters into these models, which we can actually use for configuration. So there's a few of these like that. So I was trying to actually run it on uh, Cloud Console, but yeah, for some reason it's not being generated on my. But anyway, there's a few models like these that you can actually use from your end as well, which can be useful for student projects as well as educated projects. And then we have things like Microsoft's Python. This is a news. I mean, we can't really call it a large language model. It's more or less like a lightweight model. Maybe you can even call it a small language. It's been trained on a far smaller subset of data rather than general GPT. So it has like variants which are just like it has just 4,000 parameters or 128,000 parameters, which makes it easier to run it on a laptop. Or there are even versions of this that have been optimized to run on ARM systems. Like it's tailor made for mobiles or even tablets. Uh, and then we have things like Meta's Llama model, which isn't just limited to a small model. There's a 405 billion parameter model, which is used to not just generate. It's a multi-model model. So it's not just used to generate text; it can be used to generate code, images, and also apparently 3.1 does have a video generator built into it. We are not yet publicly made it available. Another example that we can use is Sora. Sora is a closed source model. It's used for video generation, but there are open source ones coming into the picture. So Sora did create a it was kind of uh, like a turning point for most of these models because you have a simple prompt and then it generates a video out of it, which is just when you think about it, the whole sort of ethical as well as questions that it brings into the picture of what is real and what is not is a big have things like Stable Diffusion's video model, which is open source, uh, which you can actually use from Stability AI as well as Transformers. And even they are coming out with a video model soon enough to help compete with Sora on the OpenSea side of things. And you can actually use it to generate images as well as even videos or even things like storyboards or if you're thinking of an industry perspective, there are things like UI UX concepts. Maybe you might need a wireframe model for a UX design for an app. So rather than UX developers sitting across hours and generating a storyboard for it, you can actually use these models to generate a simplified storyboard, a simplified UX design for you to generate an app. So these are a few things that I can just talk from my mind. We also got things from the Indian government, things like Anuvadani. This is a platform that has been created by the Ministry of Education with a lot of tools that you can actually use. Most of these tools are also open source, like things like the virtual keyboard and even Buji. That's another document translation tool that has been indigenously developed for keeping context aware translation of documents. So there are all these things as such, and I'll just move on back to our presentation. Okay, we should be able. So that's just on the side of language translation as well as these business models that I've shown from that end. The next question that you might have is where can I run these models? So it's not always possible to have access to a large supercomputer cluster or even something like even a cloud-based platform which you might actually have to pay for using tokens to generate things. So that's where the smaller models that I showed comes into the picture. So models with like 4,000 multiple 1,000 parameters can be run on a modern laptop with mostly modern hardware. So like just giving you an example, there are these new Copilot PCs from Qualcomm or even the Intel Meteor Lake, AMD's new Zen 5 architecture chips. Uh, it comes in multiple price ranges. Yes, it does, but it also it has democratized how we can run these models locally. And the next part of thing after language translation would be text summarization. So text summarization, where you can actually see an example of this is maybe some of you might have used the Google Assistant on your phones. So recently, Google has moved on to Google Gemini on phones like Pixel or even Samsung's new phones, wherein which you can actually share the screen that you're viewing right now, and then you can actually ask the model to summarize what's on the screen. So it might be an article, it might be an Associated Press news article that you're reading, or maybe it might be a financial report from the Economic Times. So rather than just reading through the entire article, you can actually ask these models to spit out something that's a condensed form of whatever data that's available. So the advantage to this would be it basically you know uh, it's more extractive and it's also more abstract. So you can extract key points from the data that's present, and you can also create abstracts from those key points. So if you want to, expand on one particular article, or maybe something that's just present in the article as a forward, you want that to be, expanded a bit more, so that you can get an like additional insight into that. And where this comes into the picture are like personalized news digests, or something where it's tailored to more of your individual interest. So there's this platform known as Flipboard. Flipboard used to be a news aggregator which would take your interest and then provide you with articles as such. Right now, you can have something sort of like an open source version into Flipboard, wherein which uh, you can actually train a llama model on whatever interest that you have, and then rather than providing just links to certain news articles, when you wake up you can actually have a condensed input into whatever interest that you have been provided. Then let's move on to chatbots and virtual assistants. So chatbots and virtual assistants basically come into the picture where customer service automation happens. So we have things like personal assistants on our phone, like Siri or Alexa or Google Gemini, or even things like ChatGPT, which is coming out with a voice model. So these things are more context aware rather than the last generation of voice assistants. So when you think of an Apple phone right now, there's something known as Apple Intelligence, which has been built with ChatGPT. So these things are more context aware, and they're also more emotionally intelligent assistants. So they are not just, so suppose you're telling your virtual assistant on your phone to book a table for two at a restaurant of your choice. So, uh, so what Google can do right now with Gemini is you can actually dial up that restaurant that you've actually called into. Because in case it doesn't have an online portal for making bookings, you can actually dial up the restaurant. And it actually sounds very human to the person who's taking the call there to book two tables and whose names and based on like maybe currently existing things on your calendar, like maybe in your calendar you've saved that it's your anniversary or maybe it's a birthday. So based on that, actually this model can, even without you reminding it to about what the context is, it can actually provide insights into those bookings where in which it's an anniversary celebration or maybe it's a birthday, we need a cake for that. So it's more context aware in the sense it can basically use existing data that you fed into the model and then create a emotionally intelligent awareness onto what you need from it. The next thing that I would like to move on to is sentiment analysis. This is something that I've actually used in my prior engagements. So think about something like maybe a large brokerage firm or maybe even a hedge fund. I'm sorry, I guess my video went down. My camera is overheated, I guess. So I'll just go on with the general explanation of that. So yeah, on sentiment analysis side of things, think about something like a hedge fund or maybe even like a large brokerage firm, which has a large client base. And these clients might have a particular set of stocks or dividends or mutual funds that they want to invest in. And what you can actually go from this data is, rather than just giving them suggestions on, currently good stocks, I mean, stocks that are performing well, you can actually provide them more data into things with sentiment analysis, which actually takes into consideration things like news articles or maybe insider information, or even things like, rumors or accordingly create a model which basically provides you with a deeper insight into what the market might be performing down the line. So it might be a very simple thing such as uh, like maybe an industry is going to go into bankruptcy or maybe a particular industrialist has acquired a large acquisition of companies to focus more on another industry. So these things can be used to fine tune your existing model to uh, it can create this sort of like an emotional tone which can be used to provide a positive or a negative feedback into the current model that you use. And then next I would like to move on to question answering systems. So basically, what these are just uh, it's more or less like an evolution of our current chatbots or our current very rudimentary RAG chatbots that we have. So these are mainly used in like advanced search engines. So maybe some of you might remember the old search engine Ask Jeeves. It was actually more or less a single person who was providing like a more contextually aware, output into what certain search terms that we have. So where question answer systems actually provide like a change in our current usage, it can provide more tailor-made suggestions to websites that you might need for any particular institution or any particular industry that you have. And it also helps with the AI-powered research. So maybe you're having a PhD research that's happening right now, and you can actually have a context-aware or more, targeted searches into things like maybe your field of just out of my mind. I was just thinking of maybe your field of research is into uh, quantum mechanics. So in quantum mechanics, maybe you might have to look into a new processor that's coming in. Maybe Google's Persimmon has finally come into the market. Maybe you want to know the certain schematics of that processor to see if your quantum use cases might run on it. So you need a targeted search for that rather than having just a generalized. Because when you search for Persimmon or when you search for Google Coral or things like those. You might have like a lot of news articles which come out rather than things that you need, which are maybe schematics or maybe the coding languages that you might use for. So in that case, these question answering systems comes into the picture. You can also have things like text to speech for you might be an author of a particular technical document or even a fictional document that exists. And the current trend is for audiobooks, or we have services like Audible, which uses actual narrator generated books, which we can listen to on the go rather than sitting somewhere down and reading a book. You can actually listen to these books, which have been narrated by an actual voice. So the problem with this current solution is an actual person will have to spend a considerable amount of time narrating these books with correct audio intonations, as well as based on whatever context is there. If it's a fictional document, if it's like a science fiction book, based on whatever context is there in the book, the narrator will have to play it out, in essence act it out while narrating the. Where generative AI comes into the picture is you can actually have a trained model of a particular actor or a voice actor's uh, prior works, and then this model can actually generate a complete audiobook based on these prior works, obviously with the permission of the audio actor who has given licensing to his likeness. And it basically helps as sort of like an accessibility tool for even people like visually impaired to better understand what's happening on television. Like voice cloning of disease actors or actors who might have scheduling conflicts or things like that. Another thing where it might be useful for educators as such would be grammar and style checking on their articles, or with advanced writing assistance, things like Grammarly, which you might be using right now. It helps you, provide a better output into your essay scoring systems, as well as things like, AI writing coaches for different genres and styles. So I will just move on to the next part, which is content generation, which is again sort of improvement on to what you already discussed on article and report writing as well as product descriptions. On article and report writing, I don't really have to go into depth with it because I've already kind of explained what we do on that. You can have like draft articles which might give you like more ideas into, like, suppose if you're a content creator and you have an idea for a new video, or an idea for a new article that you want to write, a blog post that you're going to write, or maybe you have the occasional writer's block. So rather than going out of the field and researching and taking your time into bringing something out which might have a deadline, you can actually use an AI to generate a draft article based on what's trending right now, and then you can actually use that to better create a new article, and then do your research yourself, and then create a newer article based on it. Also, things like product descriptions. Product descriptions are where you have a new product that might be coming into the market, or a certain product that currently exists that you want to push more into the market with certain search engine optimizations or influencer content or things like that. So these are things which help with large inventories or with e-commerce sites, or even with a smaller scale. uh, and then social media content, like I explained to you, post ideas, hashtags which are there to better create sort of like a more broader outreach into your target audience. And then in email and marketing copy is something that's useful for us industrial professionals as well as for education purposes, which you might have a new course that you're going to offer. So letting a large swath of people know about this course, and also maybe generating a personalized email to certain professors that you might want to collaborate with, rather than just sitting down and typing out that mail. You can actually use a generative AI tool to generate a more personalized email based on what that professor focuses on, or maybe what that industry professional focuses on, and then you can actually send out personalized emails as well as marketing insights into these mails as well. The code generation. This would be a very controversial topic for our people here, because code generation is again something that we might not really think is right, because we have any sort of boilerplate code as well as translates any sort of natural language into code snippets. And this we can use to speed up any sort of development as well as maybe debug your existing code into or maybe even add additional functionality into your existing code. These are things which kind of have a dark side to them as well as a very positive side as well. So we'll be covering some of those concerns later on down the line. Uh, then I'll just quickly breeze through the creative applications. So in terms of like music composition, uh, you might have like any sort of uh, like a video that you have created that might need a background score, or maybe even different things like you want to replace a particular composer that you have existing with someone else, a different kind of musical style to experiment with what you have. So there are tools like Suno AI, or there are even open source tools like Magenta which you can use to generate like sort of like harmonies and melodies and stuff. And then things like video game development. So basically, in video game development, where this comes into the picture is there are characters known as NPCs in video games. So NPCs are usually a very hard thing to implement because there's a lot of background code that you'll have to write down for these NPCs, how these characters react to your characters' existing things and stuff like that. So with the advent of generative AI, what we can see is these NPCs can be coded more easily, and world building, that is your currently existing world, can be procedurally generated, which can be seen in certain games like No Man's Sky and all, in which you don't have to actually sit somewhere and just generate large worlds for your character to play in. You can actually use an algorithm to procedurally generate newer worlds or newer areas in your world. And then there's also like maybe AI opponents for existing like uh, esports players or even athletes, like things like chess or even table tennis, which recently had this AI generated opponent that we used, which used a 3D moving arm to better simulate a opponent that you have. In case of chess, you might be a grandmaster who wants to simulate a match with another grandmaster. So based on whatever prior moves that the other persons, suppose you are Magnus Carlsen who's fighting with Praganatha. So in case of Praganatha, he might actually use an AI which uses Magnus Carlsen's last moves, and maybe train himself on things like those as well. And then there's visual and spatial design. So visual and spatial design is nothing but any sort of AI generated artwork or architectural designs or any sort of smaller graphics. Just to give you an example, all the graphics used in this particular site are AI generated. That includes this whole window background, these smaller uh, images and thumbnails that I've used. These are all AI generated. The whole UX design of this presentation has also been AI generated as well. The only content that I'm using is something that I've curated or maybe adjusted in my end. So these design aspects of presentations or even things like documents that you create, these are all advents of generative AI that you can actually use. Also, that again, there will be a dark side to this. There's things like deepfake technology, which is used for film production, which can also be used for nefarious content, like we can see with election interference and things like those as well. Obviously, like every new technology that comes into our picture, there are two sides of the coin. There will be an advantage and a disadvantage, and it's up to us, the end user, to properly identify as well as create a sort of environment where in which we can actually see if something is genuine or not. And then we have fashion designing, where in which we have things like avatar generation for models, or even creating procedurally generated data on stuff. So it's not just with clothing or furniture or things like that. It can also be with architecture or interior design, and then even things like rather than this, there's also things like molecular analysis. Maybe you're bringing a new product into the market, like maybe a new shirt which is wrinkle free, But for that particular shirt, which uses maybe a polymer-based threading, maybe certain dyes won't work on. So you can actually use prior research which is already available to select the correct dye that we can use, or maybe the correct printing technique that we can use on that particular fabric. And then moving on to certain case studies. So I've already shown you a few case studies. So I'll just share something else, a few other things as well. Okay, so yeah, I've already shown you about Suno. Suno is a platform that you can use to generate music. So this has been a bit controversial as of now because certain artists have claimed that their likenesses or their melodies have been used to train this without their permission. Or maybe you have something like Claude. So Claude is LLM that's been created by the company Anthropic. And in my honest opinion, I feel like Claude is one of the best chat assistants that you can actually see. So you might have something like a simple query that if you can generate an ASCII image, and then it can provide you with a few examples of those as well. And then you can ask it to maybe generate something that's more complex, and it might have mixed results. But at least what happens is with in the case of Claude is uh, the output that comes from Claude is the most human sounding outputs that I've seen. Or even with ChatGPT, which has been trained on a larger subset of data, which has actually signed on things with companies such as Reddit for getting more human data available, or even things like even larger companies like Disney in this sense. Like query I asked was, can you narrate the tragedy of Darth Plagueis the Wise, which is a dialogue from the movie Star Wars Revenge of the Sith. And it's actually verbatim the dialogue that's been spoken in the film. And this is actually used with permission from Lucasfilm as well as Disney, I guess, who's the current owner of Lucasfilm, to better provide insights into this as well. But this also provides another side into these models, where in which certain data might be aggregated, might be crawled through without permission from their users. So an example of this would be Google's Gemini model, which has mired into a bit of controversy as of late, wherein which these models have been trained on data that isn't really taken with adequate permission from the user. And then if you're actually looking into something such as AlphaFold, I'll just show you that as well. So in medicine, we have these things known as protein structures. I'll just show you an example of protein structure as well. So these protein structures are, in essence, complex three-dimensional shapes, which are the actual personification of a particular protein. So a protein, in the sense, it might be maybe a disease receptor, or maybe a virus receptor, or a virus target point, which is in its essence a large amino chain, a large chemical chain. And the thing with these proteins are these are folded into a particular shape. So these will have like a particular structure. And the only way you can target these proteins is by unfolding the structure. And this is more complex than we think of it, because it's not like a simple helical structure. It might be multiple helixes, it might be multiple complex shapes that are folded into each other. And prior to the advent of generative AI, a researcher had to sit for maybe the better half of months or even years trying to unfold a protein to better create drugs that are targeting these particular protein receptors in or maybe even create vaccines that target these protein receptors in viruses itself. So AlphaFold is basically an algorithm which was developed by the EMBL, which is I'm guessing European Medical Biolabs, for unfolding these proteins. So it's developed in conjunction with DeepMind, wherein which we have a very complex protein structure. For in this case, it's the malaria parasite, which which has this very complex helical as well as double helical protein structure, which has been unfolded by AlphaFold into create a more targeted drug rather than the broad spectrum antibiotics that we might use, and which is also causing problems right now with antibiotic resistant bacteria. Where in which rather than creating a broad spectrum antibiotic, you can have medication which is designed to target the malaria parasites exact protein, which will cause it to completely it basically dissolves the parasite within itself by targeting this particular protein. It's also being used for things like CRISPR. CRISPR is another field where AI has uh, kind of caused a foothold. CRISPR is nothing but just targeted, like it's basically targeting your gene structure. It's designed to modify your DNA which is present in your organism, in an organism, and then you can selectively remove certain traits from if it's suppose if it's a variety of rice that we are cultivating. You might want the plant to be shorter, but you might want the number of stalks in that particular plant to have more grains of rice. So these are things that we can actually use with CRISPR to target that, and then you can actually use an AI powered algorithm to optimize a large set of crops rather than focusing on just a single crop. You can actually program it to focus on the large set of crops. And then after this, like what I can probably say is drug discovery. Drug discovery is again another field based on protein structure, maybe. But other than just protein structure, it can also, focus on things like the chemical analysis of drugs. So let's move back to our presentation. Yeah, please just go ahead. So drug discovery is nothing but certain chemical analysis that might be performed by pharmaceutical companies. The thing is where this comes into picture is maybe a new drug is being done. So right now there's this drug known as Ozempic, which is nothing but a semaglutide of a protein, which is like designed to inhibit your appetite. So for people struggling with weight issues as well as like things uh, like higher blood sugar and stuff like that, we can actually have things like generic drugs which are used to provide a cheaper alternative to brand name drugs. And rather than spending lots of time and resources to develop this one protein or this one chemical compound that is needed in this drug, you can actually have an AI that is trained to give an output on how you can easily replicate this particular chemical compound, then provide a different outlook onto that. And then there's AI powered personalization. So this is something that we can see with some of our phones nowadays. So maybe when you set a new wallpaper, you can see that your color palette is being changed. So this color palette detection is something that's being used by AI to suggest a particular palette of colors for your phone to accordingly change with your wallpapers. Or even maybe you're taking a photo with your phone, and there are these complex HDR algorithms that run in the background, which do nothing take the context of the image that you're taking in, and then provide like an insight into what lighting conditions that we can use, or maybe what shutter speed or things like ISO that has to be adjusted. And then game playing and strategy, I've already mentioned things like where it might come into the picture of actual sports people or even actual video games that come into it. And then moving on to like future trends in this, so where we can see like a significant insight into where this might be. So in educational and training, where we can see is since there's a growing need for tailored educational content that's needed. So with based on what happened during our pandemic, we had mostly moved on to an online-based system for education. So since that's mostly reflecting a growing importance in that learning experiences, there might be a 20% increase in current AI platforms. Based on current projections, at least from what I've seen online, there might be a 20% increase in these applications that might help in that particular industry. And in scientific research, it plays a crucial role in which it can provide data abstraction or maybe even isolate data or provide talking points for researchers to focus on with their presentations as well as their newer domains of research. And then there's AI augmented creativity tools. We can already see the advent of this in our day-to-day lives. So if you basically check any new tech presentation from any new tech company right now, they're focusing more on AI as a creative aspect. So things like image generation or image manipulation. You know, you have already taken a current image and maybe you want to remove certain aspects of that image with generative fill or adjust the position of certain people in one image from one position to the other. Again, we're using generative fill as well as generative movement. These are all things that have already started permeating into the market with multiple providers as such. And then it's already providing a deeper insight into what happens as well. And then we have multimodal AI systems, which is something that I had talked on about earlier. So these are models which are not just uh, just focusing either on text or just on image or just on audio or video. These are models which are general in the true sense of the word. These can focus on all these different aspects. And most of the newer research and newer projects that might be coming into the market will be based on these multimodal AI systems. And this is something we can actually witness within the industry as well. More and more customers are actually asking for multimodal AI systems that they can implement into their workforce. And then, yeah, there are these emerging issues that I had briefly touched on earlier. So there are obviously ethical concerns. So things like deepfakes have been used for nefarious concerns, from everything from election interference to creating completely fake videos of which might be used to discredit or disenfranchise a particular user or a particular political party or even an industry or an institution as well. And then there are copyright and intellectual property challenges. This is nothing but when all these models require a large data set in order to be trained in. And the major issue with these large data sets is you might be infringing on intellectual property, be it a company's property or be it an individual's property. There is an emerging need for these large data sets to be vetted and then, focus more on just things like it's nothing but lawyers will have to go through these data sets. They'll have to make sure that no data that's being used is they have to get the adequate permissions or the adequate licensing for those data. And then there's this major trend of job displacement and workforce transformation which might happen due to the advent of generative AI. Although we can't say for certain that there will be a major change into current industrial trends, there might be actual impacts onto certain industries such as copywriting or maybe things like proofreading, or even a developer such as myself, we might lose out to the edge provided by these creative AIs that come into the picture. Obviously, we are the ones creating these algorithms, and we might also be the ones that might be targeted by them in the future. But at the end of the day, all these algorithms are just rehashing currently available data into a different form. So it's no substitute for human creativity. It's not something that we'll actually have to fear because at the end of the day, human creativity is paramount. Whatever you might create from your insights into your you know uh, industry that you've been working in, or in case of you educators, you've been in the education industry, You found out novel methods to teach your students, to make your students understand that. And at the end of the day, no AI is going to substitute. Even with the amount of training or data sets that might go into the picture, human creativity and ingenuity is something that will be hard to challenge at the end of the day. Privacy and data security is again another uh, aspect where uh, there will have to be actual uh, legislation that will have to come into the picture for addressing the privacy concerns. Because maybe you might be searching for yourself on Google, and then maybe you might be searching for yourself on one of these GPT models as well, and then you might be concerned with whatever information is present. So there will have to be actual legislation which will have to be brought in by governments or by institutions to better curb the usage of these AI systems for nefarious purposes. That's where the regulatory landscape and these future policies come into the picture. So this is something that will have to be used with, not just with currently existing policymakers. This is where actual industry professionals, actual educators, maybe students, and even end users will have to come in and demand for change for these forefronts. So yeah, we are actually approaching the end of our presentation. So in conclusion, generative AI is a transformative force. It is causing us to rethink existing industries. It's already reshaping current industries in a very large way. There are obviously a lot of concerns that come into the picture. There are obviously a lot of advantages that we cannot ignore. That we'll have to actually implement these generative AI solutions into our existing workflows, or maybe reshape our existing workflows to better include these platforms as well. There will be ethical impacts. There will be societal progress that will have to, for the lack of a better word, there will be a large bulldozing of current industries. There will be a large rethinking of how current industries work as such. And these are things that we'll have to address as generative AI does progress. So I would like to take this time to maybe take questions from you on what we've covered so far, or maybe something that I might have to maybe provide a deeper explanation on, or maybe something that I've missed to missed in my presentation that you might need an insight on. I'll be taking questions right now, and yeah, we can maybe see if I can help you out with those. So you can actually, I think you can actually mention those questions within the messages platform in Google Chat, or you can just directly ask me questions. Don't worry, I won't bite. I am still very much a student of you, Jesus. It's been a massive honor for me just to be with Prasad once again. So please do ask any questions. If it's something that I can clear from my end, I'll try my very best to clear it.
So, since rather it was a journalistic topic, and it was covered in a very nice manner, and you just introduced us to the various use cases connected with each of the domains, and you also basically introduced us to the various tools that can be incorporated into when we think about using generative AI in a specific field. And you also took us through the popular tools, as well as you illustrated how this can be used to create images, then produce text, and how can we create videos from text. So this rather it was a very informative session, and we actually didn't have much of an awareness on as to which all tools can help in which all use cases, and what are the different use cases connected with different domains that we can have. So that was a very informative session actually, and
It's like we got to explore more on each of these areas and the about regarding the tools that can be incorporated into. So that has to be explored, and then only we'll be having much of the questions to be addressed. So the participants, if you have got any questions, you can just ask or just put in the chat box so that it can be answered by the resource person. There are no more questions. We can just wind up the session. So, on behalf of the Department of Computer Applications and FISAT, we are very happy to thank you for cooperating with us for this faculty development program and for sharing your valuable thoughts with us and for taking us through the world of generative AI and the use cases associated with the various domains. How different tools can help in different use cases. All those topics you have taken us through. So thank you us for sharing your insights with us and for cooperating with us in this faculty development program and sparing your valuable time for us. And since being an alumni of FISAT, we're very proud and blessed to hear from you. And all the best for you, sir, and all the best for all the participants. And thank you all for being with us and being in this informative session. And have a nice day.
Yeah, thank you. Thank you.